Hello everyone, good afternoon. I hope all of you are safe in home, don't come out, stay at home and be safe. Okay, now we are starting the video session for your system simulation and modeling. We were in second module, that is random numbers. Now I'll just explain you about tests for random numbers. Means here first we must know why we need to test the random numbers. Once the random numbers are generated, we have to ensure the statistical properties of random numbers. We have already discussed the properties, that is uniformity and independence. So for this uniformity and independence, we have to just test the random numbers whether it is uniform or whether it is independent. Okay, here we have mainly two tests, that is frequency test and autocorrelation test. To check for the uniformity, we have to use the frequency test. To check for the independence, we have to use autocorrelation test. First, I'll just show you how you have to test for the uniformity. Means this is test for uniformity. The hypothesis is as follows: H0 and H1. These are the hypotheses. H0 Ri, it is a random number, is uniform in the interval 0 to 1. That is between 0 to 1 if the random number is uniform. This is the symbol to denote it is not uniform. That is H1 random number is not uniform within the interval 0 to 1. And the next is testing of independence. So here also I'll just use the hypothesis. This is same as the uniformity. This is just the general thing what we are seeing for testing of independence and uniformity. That is random number is said to be independent and random number is not said to be independent. Okay, here for each of this test for uniformity and independence, we need the level of significance that must be stated, that is called as your alpha. Here first, this alpha is the probability of rejecting the null hypothesis when the null hypothesis is not true. Okay, with this alpha you can, this is the probability of rejecting the hypothesis when the hypothesis is not true. Not true in the sense you have to just decide whether it is uniform or independent. If it is not uniform, then you have to reject the hypothesis. In the same way with respect to the independence, if it is not independent, then you have to reject the hypothesis. Here mainly we have two methods to test for uniformity. Okay, here first we'll just go with the test for uniformity. We have two methods for testing, that is Kolmogorov-Smirnov test. This is also called as KS test. And one more is chi-square test. First we'll go with Kolmogorov-Smirnov test or the KS test. See here, first this Kolmogorov-Smirnov test is used mainly for the uniformity, whether to check, means it is used to check whether the given random numbers are uniformly distributed or not. Here we need to compare this function f of x of the uniform distribution with the empirical function Sn of x for the sample of n observations. Means n is the number of random numbers. With respect to this n random numbers, means the number of random numbers, we have to just compare this f of x and Sn of x. Here f of x is equals to x. Okay, and then this Sn of x, how will you just calculate this Sn of x? Sn of x is the number of random numbers divided by the total number of random numbers. For example, if you have 10 random numbers, means n is equals to 10. Okay, and this is the probability. Always we'll just take, this can be calculated by using I divided by n. This one I'll just take it as I divided by n. Okay. Now we have to just see the steps we need to follow this Kolmogorov-Smirnov test. First, what is the first step here? Here the very first step is first rank the data from smallest to largest. Means here if any random numbers are given, you have to arrange the random numbers in what? Increasing order. Okay, so R1 is less than equal to R2 till Rn. You have to arrange the random numbers in increasing order. Next, what we have to do here, we need to compute D plus. D plus is equals to max. This is the formula to find out the D plus. I divided by N minus R I. And then D minus. That is Ri minus I minus 1 divided by N. You have to just find out the D plus and D minus. Now, you have to just find out the maximum among this D plus and D minus, and then we have to compute D. The maximum of D plus and the maximum of D minus. Among these two, D plus and D minus, which is maximum, that one I will consider as D. Okay. After this one, what we have to do? We have to just take the critical value, that is D alpha, for the specified significance level alpha and the given sample size N. Always alpha will be given in the question. For this alpha, you have to just find out the critical value. This critical value can be found out using this case critical values. The table will be provided for you. From that table, we have to just take this value and then we have to see the D alpha value. Once all these are done, that is finding D and D alpha, you have to just check whether this has to be rejected or it has to be accepted. When you have to accept and when you have to reject. The last step, if D is greater than D alpha, that is your critical value, then H naught is rejected. Then you will say the numbers are not uniform. If D is less than or equal to D alpha, then H naught is accepted. That is, you will say the numbers are uniformly distributed. Okay, these are the 5 steps you have to follow. The very first step is you have to just arrange it in increasing order, then compute D plus and D minus, the maximum of D plus and the maximum of D minus. After that, you have to find out the maximum among these two will be called as D. Your D will be called as your uniform function. Okay, uniformity function. Then what you have to do, you have to find out the D alpha by the given value of alpha. Then you have to check whether D is greater than D alpha or whether D is less than or equal to D alpha. Then you have to say whether the hypothesis is accepted or rejected. Now we'll move on to the problem. See, the random numbers they have given 0.44, 0.81, 0.14, 0.05, 0.93 are generated using KS test, that is your Kolmogorov-Smirnov test. Then compare f of x and Sn of x on a graph. Alpha is given, that is alpha is equals to 0.05. This is our problem. Now we'll move on to the solution. How you have to just do this one. See, this is the solution here. First, what is the first step? I, the random numbers 1, 2, 3, 4 and 5. Now let me come for the solution. Here I have n is equals to 5 because we have 5 random numbers in the question. So n is equals to 5. So I am just taking each and every random numbers I from 1 to 5. This is Ri, the random numbers 0.05. I am just writing it in increasing order. This is the first step. First you have to arrange all the random numbers in increasing order. That is your ascending order. That is 0.05, 14, 44, 81 and 93. And here you need to calculate I divided by n and I minus 1 divided by n. For this one, I am just calculating I by n and I minus 1 by n. I by n, that is I value is this one, 1 divided by 5, that is 0.2, 2 divided by 5, that is 0.4, 3 divided by 5, that is 0.6. Likewise, I have calculated. In the same way, I have calculated I minus 1 by n. These are the values for I minus 1 divided by n. Then the second step is you have to calculate D plus and D minus. The formula to find out D plus is I by n minus R and D minus is Ri minus I minus 1 divided by n. With this, I have calculated these values. This is the second step, calculation of D plus and D minus. Then the third step, what is the, in the second step itself, you have to find out the maximum of D plus and maximum of D minus. Which is the maximum number among these? 0.26 is the maximum number. So I am just selecting this as D plus. And among these, 0.21 is the maximum number. So I am just selecting the 0.21 as D minus. Okay, now my D plus is 0.26, D minus is 0.26. 0.21. And what is the third step? See here I have taken D plus max is 0.26, D minus maximum number is 0.21 I have taken. Now what is the next step? You have to find out D. Among these D plus and D minus, which is maximum, that one will be considered as D. Yes, now here see D is equals to max of D plus D minus. Maximum of these two is which one? This is 0.26. This is the maximum. So I'll just take 0.26 as D value. That is D is equals to 0.26. Now you have to find out this D alpha value. Okay. Now what is D alpha? D alpha comma N. That is 0.05. Alpha value it is given in question. See alpha is equals to 0.05. So D alpha comma N. Alpha is 0.05. N is 5. Already we know. So this value you have to find out. From where we have a KS table. From that KS table you have to find out this value. I'll just show you the KS table. See here this is the KS table what we are seeing. Here where is alpha 0.05? It is already given. Alpha is 0.05 and then see alpha is 0.05 and N value we know it is 5. Alpha value 0.05, we have a value 0.565. Like this you have to find out this value from your KS table. 0.05 alpha value and 5 N value. In this what is the value? This is your D alpha comma N value. Now come here. See D alpha comma N, that is 0.05 comma 5 is 0.565 from table. Already we have got this also. Then now you have to find out whether D is greater than this D alpha or it is less than the D alpha. See 0.26 is our value. 0.26 is less than your D alpha value. So you have to accept the hypothesis. If it is D less than equal to D alpha, then you have to accept. If D is greater than D alpha, then you have to reject. Now 0.26 is less than 0.565, so you have to accept the hypothesis. Now you can say the numbers are uniformly distributed. Okay, this is how we'll just do the KS test, that is Kolmogorov-Smirnov test. Now in the question, they have just asked you to compare f of x and Sn of x on graph. Now I'll just go to the graph. How you have to plot the graph. See here, this is the graph we need to plot. Now here I'll take Ri, that is your random numbers, and here I'll take the cumulative probability, that is I by n, what we have calculated in the table. See, I'll just plot Ri, that is 0.05, R1 0.05. The first cumulative probability is 0.2 for that one. I'll just mark it like this. Then R2, it is 0.14 and I by n value is 0.4. I'll mark here. Likewise, random number R3 0.6, random number R4 0.8, random number R5 1.0. You have to just join all these things with respect to this center line. Now here this part is your D plus and this part is your D minus. See, this is D plus and this is your D minus. In D plus, which is having more area, that one you have to consider because we have to find out the maximum of D plus. See here, this one, this, let me come for the graph now. This is, I'm plotting the graph by Ri to cumulative probability I divided by n. Both the values we know, I divided by n and Ri, that is random number 1, that is 0.05. I'll just take this and it is 0.2, then R2 to 0.4, then R3 to 0.6, then R4 to 0.8 and R5 to 0.1, that is 1.0. You have to just join all these things like this, and now you have to find out D plus and D minus. We'll just take the upper part as D plus and the lower part as D minus. Now here three areas are exposed in D plus. Among these three areas, which is maximum you have to take, and that one you have to mark as D plus, that is maximum of D plus. So see, this is the maximum area which is exposed in D plus, so I'll just make it as D plus 0.26. And in the same way, if I come to the lower part, see, this is D minus. Here also three areas are exposed in D minus, but among these three, which is most exposed, which is maximum exposed area, this is the maximum exposed area, so I'll consider this as D minus, that is 0.21. okay, and here this one I'll just consider as f of x, and this line what we have, this one I'll consider as Sn of x. This is your graph, and this is your complete